There are three major types of polymers: semicrystalline, liquid crystalline, and amorphous. Give an example of each naming the polymer. Given an unknown polymer, what one experiment would you perform to identify which type you had? What major behavioral differences would you expect among the three types? For part A, an example of semicrystalline polymer would be polyethylene. So polyethylene is semicrystalline at room temperature. An example of liquid crystalline would be polyparaphenylene terephthalamide. An example of amorphous would be polymethyl methacrylate. Polymethyl methacrylate is below its glass transition temperature at room temperature. Um, Polyethylene is above its glass transition temperature at room temperature. Given an unknown polymer, what one experiment would you perform to identify which type you had? We can heat the polymer and study the effect on temperature. For a semicrystalline polymer like polyethylene, the graph of temperature versus heat would be like this. It will undergo a first order transition at its melting point, whereas an amorphous polymer will undergo a second order transition at its glass transition temperature. A liquid crystalline polymer behaves like this with increase in temperature. The polymer will first melt into the smectic mesophase, and then with further increase in temperature, it will do a first order transition to the nematic phase, and with further increase in temperature, it undergoes another first order transition to the isotropic phase. The polymer is a liquid here, and here it is an anisotropic, and these are all first order transitions. What major behavioral differences would you expect among the three types? Regarding mechanical properties, amorphous polymers have less tensile strength compared to crystalline polymers. Crystalline polymers tend to have higher tensile strength. Liquid crystalline polymers have very high tensile strength, especially rod-like shaped polymers, which is why they are used in making high tensile strength fibers. The density of crystalline polymers is higher than that of amorphous polymers, and liquid crystalline polymers also have high density. Chemical resistance is extremely high in liquid crystalline polymers. Chemical resistance of crystalline polymers is higher than that of amorphous.